Okay, in this video we're going to talk about how those formed elements are produced, or where do they originate from. So the term that's used for the production of all formed elements in your blood is called hemopoiesis. So if I can get my cursor to work here, let's try this. Hemopoiesis. And hemopoiesis is defined as production of all formed elements in your blood. Okay. Now that would include red blood cells, it includes the white blood cells, and it includes the platelets. Now there's individual terms or specific terms for those individual elements, but the overall term is called hemopoiesis. So what we're going to look at are your three different types. One's going to be erythropoiesis. And this is going to be production of red blood cells, also known as erythrocytes. Thrombopoiesis. This is going to be platelets. And leukopoiesis. And if you can guess that one, that's white blood cells. So we're going to look at each one of those components in the next 3 videos, this video and 2 more videos, and we'll discuss the specifics about that. So pause 1 second and let me change the video here for real quick. Okay, all 3 of these processes or hemopoiesis can be summed up in this table that you're looking at right now. So let's just break it down into the component parts, figure out what's happening. So all the formed elements, and the formed elements are everything that's at the bottom here. Let me see if I can get my cursor going again. I don't know why it's not doing it. There we go. So let's try this. There we go. Okay, so all our formed elements would be seen down in here. So we have red blood cells, or the erythrocytes. We have platelets. We have something called granulocytes, monocytes, and lymphocytes at the very bottom. Okay, but they all originate from that top cell. That top cell is a stem cell, and it is a multipotent stem cell, meaning that stem cell can differentiate into a variety of different cell types. Okay, that stem cell is called a hemocytoblast. So that's where everything originates from. When the hemocytoblast begins to differentiate or specialize, it can go in one of 2 different directions. Let me get rid of that. It can go in one of 2 different directions. It can follow the myeloid line. So let me just write this out. M-Y-E-L-O-I, myeloid line. Okay, let's go that direction. And the myeloid line is going to be responsible for red blood cells. It will be responsible for platelets. And it's going to be responsible for granulocytes. And it is going to be responsible for a monocyte. Just as an FYI, all of those down here, those are white blood cells. Okay, depending on the type of what type of white blood cell determines which line that it's going to stem from. So let me just get rid of that. So those are following the myeloid line, and the lymphoid line coming from down here. Lymphoid line is going to be responsible for lymphocytes. When we discuss in a couple more videos Lymphocytes, white blood cells, we'll go into much more detail on the different types of white blood cells and what each one of those do. So we're going to compare and contrast on some of those. For right now, let's just follow the erythrocyte line. So we're going to go this direction first, okay? So the hemocytoblast will differentiate. It will go towards the myeloid line, so it becomes a myeloid stem cell in this one, okay? And we're going to skip a couple steps because I don't really, I'm not going to hold you responsible for some of the different steps. But as the cell differentiates, it's going to change. You can see the different cells change into various stages, okay? Some of these stages, like the proerythroblast, early erythroblast, essentially what we're doing is we are putting a lot of hemoglobin in the cytosol. That's going to be the key thing on this one. We're producing ribosomes in those areas. But one thing I want you to notice is that the nucleus, that large part here, is slowly getting smaller. The cell is getting smaller. As you can see, the cell size here versus the cell size way up on top, the cell has reduced in size. The specific stages that I want you to be aware of is going to be the normal blast, which is going to be this one. And the key issue on this one is this little part down here where the nucleus is removed or ejected from the cell. Okay? When we look at the red blood cells don't have a nucleus. It doesn't have cellular organelles in it. Okay? So that's the mature red blood cell or the mature erythrocyte. So we have to get rid of the nucleus. So as you can see, the different stages, the nucleus gets smaller. It's eventually ejected from the cell. What remains in the cell at this part, most of the organelles, cellular organelles, are going to be in the process of being removed. We have hemoglobin in that cell. And then when we get down to the reticulocyte, let me erase a little bit of this so you can not have it over. Oh, I don't like that. So let's see if I can just back that up. There we go. Okay, so when we're looking at that, this is the normal blast. The next one down is going to be the reticulocyte, which is going to be that level. And again, this is the cellular level where the nucleus is gone, but you can still see those little dots within that cell. Those are going to be ribosomes. Ribosomes are going to continue to produce hemoglobin. Hemoglobin's found in the red blood cell, which then carries the oxygen. It gets moved into your bloodstream where it begins to mature. Okay? And a mature erythrocyte no longer has the ribosome. So what we're looking at the mature state is roughly a membrane-bound sac of hemoglobin. That's essentially what it is. The reason we don't have a nucleus, the reason we don't have cellular organelles is, well, frankly, they use up the oxygen. And the purpose of the red blood cell is to carry oxygen from one place to another. So we don't want to use up any of the oxygen to get it to where it's going. That would be like being an ice cream truck driver, Haagen-Dazs truck, okay? Well, their responsibility is to take the product, the ice cream, to the grocery store. You don't want the driver eating the product. You don't want the driver of that truck to eat the ice cream because then wherever you're going to end up doesn't have what they wanted, okay? So this is the same idea. We don't want the nucleus or the various organelles to use up the oxygen that needs to be transported to its destination. So let's look at this. We'll talk a little bit more about the granulocytes and lymphocytes and platelets for that matter, a little bit later on in another couple videos. So stay tuned for that, and we'll be right back. Thank you.